All right, guys, so we're going to be talking about two-dimensional collisions. Two-dimensional, don't think about it too much. Basically, it means that instead of just going, forward and backward, it is just something, one object will run into another object, and they will shoot off at different angles. It's that simple. It's that easy. We'll go over how to talk about it, how to look at these problems, and what to look for, how to solve them. So first, what you're going to be given is an initial state, all right? So you say, I'm going to draw big pictures here. I expect you guys to draw big pictures too when you solve these. We got ball 1 and we got ball 2. We'll say the initial state of ball 1 has a mass that's equal to 3 kilograms and a velocity equal to 2 meters per second. And this has a mass equal to, we'll say 1.5 kilograms, and it's at rest. So the velocity is equal to 0 meters per second. All right, ball 1 hits ball 2, and they fire off in different directions. Ball 2 goes up this way, and ball 1 goes down here. But let's go back to our ball 1 first. So initially, what is the momentum of the system? Well, it's just ball 1 because ball 2 isn't moving at all. So ball 1, the initial momentum, we know that, and I'm going to draw my box right here, I know that to be 6. And from now on, momentum, we're not going to really worry about kilogram meters per second. We're just going to call it P. So 6 momentums, 6P. It's going to be a lot easier to write because there's a lot going on with these. So 6P. Now, ball 1 hits ball 2. We'll say ball 2 flies off at an angle of 30 degrees. And it has an initial velocity, or it has a velocity of we'll call it 0.95 meters per second. So it flies off at 30 degrees with a velocity equal to 0.95. Well, let's find the momentum that is, how many P's that is. So we'll just go 0.95 times 1.5. And that gives us 1.425. So really, what we have right here on this hypotenuse is 1.425 P going up at a 30-degree angle. Remember, because the velocity is equal to that. Like, the velocity is within this angle, so we don't have to worry about sine or cosine with the velocity. We only have to worry about it coming up. So I'm going to shorten these so I can show it better. All right. So then, there we go. There we go. All right, cool. So something interesting to note and something important to note is that there's two different momentum vectors. We have the x momentum vector, and you guys should remember this from projectile motion. We have the x and we have the y, okay? So starting out in the y, there's nothing. There is no momentum in the y. Why is that? Well, it's moving directly horizontal, right? There's no up and down motion to this. So there's no momentum in the y right now. So what we'll do is we can calculate the momentum that this ball 2 feels, right, going up this way. We can calculate that momentum, and it's going to be the same as the momentum that ball 1 feels going downwards. All right, so let's calculate ball 2's momentum. Well, do that very easily. We'll say 1.425 times sine of 30 times sine of 30. We get 0.7125 P. Very good. So now we know that it's actually the same as right here. So we can actually write that 0.7125 P. Now let's find this x momentum. And before we do that, I want to say there's something important to note. We started off with 6P, right? 6 momentum going in the horizontal direction. You guys remember that conservation of momentum states that whatever momentum you start with, you have to end with. So in the horizontal, right? And we actually see this with the momentums in the vertical, right? We started with 0, and now we have opposing momentums. So these both cancel out, so it's still 0. So if we start with 6, that means we have to end up with 6 going this way in the horizontal. So how much of that 6p comes from the ball 2? Well, we just do that by doing 1.425 times cosine of 30. So let's type that in, 1.425 times cosine of 30 equals, so 1.23p of this 6p is coming from ball 2. Now we can see that, and I'll actually draw ball 1 right here. This isn't to scale, this is just to show the fact that ball 1 is going down this way. So how much of this horizontal 6p is worth of ball 1? Well, we just subtract it out. 6 minus 1.23 equals 4.77. 4.77p is this horizontal, the px. So we're also looking for the angle, and we're also looking for this momentum right here. Let's find the angle. This right here, we have an opposite over an adjacent, so we can call that tangent, okay? And we know that tangent of theta is equal to opposite over adjacent. So to find the angle, let's say theta is equal to the inverse tangent of 0.7125 over 4.77. So let's try that. 0.7125 divided by 4.77 equals, so now we have to do the inverse tangent of that answer right there, and we get an angle that's equal to 8.5 degrees. 8.5 degrees. Now we can find this hypotenuse, and we can find out the momentum that ball 1 feels at 8.5 degrees. So we can do that one of 2 ways, or one of 3 ways really. We can use Pythagorean theorem, a squared plus b squared equals c squared. We can use 4.77, or we can use cosine, or we can use sine. The easiest way, I think, is to use Pythagorean theorem, because we just add them together. 4.77 squared plus 0.7125 squared equals, and now you just take the square root of that answer. And you get down here, the momentum is 4.82p. So that's how you really want to solve these. And finally, we can find the velocity that we feel. Remember, if we had this momentum that it has right here going in that direction, what's the velocity? Well, we just divide by mass. So we say 4.82 divided by 3 equals v is equal to 1.61 meters per second. So these questions I ask you are going to ask you a lot of questions within one, right? So it's not going to be a lot. These are all answers that I expect you to be able to get. Right here. Those are all answers. Everything that I've boxed in, I expect you to be able to get, just from the knowledge that we have here. And I want to clarify some verbiage or some symbols that I use. So when I talk about the momentum of a ball, I'll just write that as P, right? If I talk about the momentum of ball 1 in the x direction, so 1.23, I'll write that as P1x. Sorry, this is number 2. Let me do that. So the momentum of ball 2 in the x direction is just P2x. The momentum of ball 1 in the x direction is P1x. And vice versa for y, right? P2y, P1y. Those are the different, symbols I'll be using. And this general P, right, without any sort of subscript down here, that is your hypotenuse. That's your hypotenuse, because that's the resultant. That's what it actually is doing. So we have to clarify if it's an x or y, but we don't have to clarify if it's in the hypotenuse. We just write it as just a p. So that's what your homework looks like. Give it a shot.